Assalamualaikum. We are doing 2022 SA1 paper for PU1 Iman, Maths HL, paper 2. This time, question 6. Alright, let's read question 6 first. It is about this parachutist, okay, or skydiver. Okay, so the question goes: the downward speed v in meters per second of a skydiver t seconds after a jump from a plane is modeled by the piecewise function given as such. Okay, so there's two parts. Okay, this earlier part and then the second part. Okay, the domain, right, is not explicitly given. Okay, it's given as capital T, so we don't know when this stops and this starts. Right? Okay, first question is show that k is equals to 60. Okay. Okay, so to start off, okay, k only belongs to the first function. Okay, so what we can know when the skydiver wants to jump, okay, is that the initial velocity. Okay, that means when time is equal to 0, okay, before he even starts diving, okay, his velocity or her velocity should be 0 as well, because you haven't even started moving yet. Okay, so therefore v0 is supposed to be 0. Okay, when time is 0, it's supposed to be 0. Okay, so when you plug this in, you get 60. Okay, you see when you plug in 0 over here, okay, it's 60 minus k over 1. Okay, so k over 1 means k. So 60 minus k is equal to 0. So k bring over right is equal to 60. Okay, so sure. Okay, so use the initial velocity concept, okay, to arrive at k. Okay, moving on. They ask you to draw the graphs of y equals to 60 minus 1. Basically, these two graphs. Okay, so you just need to plot it under the y1 and y2. Just change all the t to x. Okay, the rest should be okay really. The k this time is already 60, so just plug in to 60. Okay, so when you plot, this is what you get. Okay, the green one is the first one. Okay, the red one is the second one. Okay, so maybe to guide you, maybe I just color it. Okay, so this is red, and then this is green. Okay. Alright, so that is just a plotting. Okay, so for plotting, right, okay, what you can do is when you set the window setting in your GTC, right, okay, you follow the scales in your question. Okay, so your question gives from 0 to 60, okay, or maybe lesser than that. Maybe you can start from negative 10 or something like that. Okay, so negative 10 to 60, the y-axis as well, negative 10 to 60. But if you notice, right, the x-axis, the interval is in tens, so your x scale, you should set it to 10, and then your y scale is 15, intervals of 15, so your y scale, you set it to 15. Okay, why you do so is that when you do as such, right, your GDC is able to tell you where it cuts exactly at the axis. Okay, the markers will be there, okay, so you can estimate, oh, is it on the first one, second one, below the first one, below the second one, or something like that. Okay, so your drawing will be more accurate. If you set a different scaling, right, for instance, if you set your y to be in scales of 10, okay, so then you may misinterpret and then think that, oh, this one is actually on the third one, then you will actually draw it a bit higher. Okay, you end up drawing it wrongly. So take note of that. Your scale in your GDC should follow the scale of the question. Okay, right there. Okay, so now the next one is find the time t at which the skydiver opened their parachute. Okay, so this way your concept comes in. You see, first, do remember that the green one is the first one. Okay, that means you must start with the green one. Okay, so the anything here on the red is none of your concern because we are not at the green. Okay, so what happens is the diver will start to be jumping up. Okay, then you think of it. Okay, this one is a bit of concept. Okay, you need to stop somewhere. Okay, between the first equation and the second equation. As we learn about piecewise function, the moment this ends, the first equation ends, is when the second equation begins. So they need to be at the same number, okay, for it to be a continuous function, right? Okay, we learned that before. Okay, so now we have two possibilities. Either you jump here and then over here this change, okay, or you jump here and then over here they change. Okay, so this is where the concept comes in. If you choose here, right, okay, you notice that the change, right, takes a certain amount of time first before it drops, the velocity drops. So technically, the velocity still remains at that speed and then goes down. Okay, right? So if you visualize you're diving, okay, you open the parachute, you still go at that particular speed, and then later on somehow you slow down, which kind of doesn't make sense. Even in the movies also you don't see that. Okay, you jump like that very fast, then you open a parachute still fast, you'll be scared. You'll be scared to death because it's still fast after you open the parachute. So it doesn't make sense. Okay, but on the other hand, you choose the other one. Okay, so you're diving very very fast. Suddenly, when you open the parachute, this point, the speed suddenly drops. Okay, so if you see the movies, right, they jump and then very fast, and then suddenly when they open up the parachute, then you're like, okay, they start slow down, slow down, slow down. Okay, I know this because last time when I was young, there's this virtual reality. During my time, virtual reality is not a common thing. Okay, so I play this parachute game. So I just stand there and then I control right hand. So I move like this, then the computer will move my hand and all that. So from there you can see that the jump is very, very, very fast, and then suddenly when you open our parachute, it will be like sudden. Okay, so we need this sudden here. So actually the moment that you open the parachute should be here. Okay, not here. Okay, anyway, it's a bit too soon now. You jump and then suddenly you open the parachute. It doesn't make sense logically if you see from time alone. Okay? Alright, so what you need to do, you need to find the intersection. So that will be your GDC. So just go to your GDC, calculate. Okay, second calculate, and then after that find the intersection. I think the intersection should be at time t equals to 29. Okay, so when they open, he or she open the parachute. Hold on, and that will be, oh sorry, it's capital T. Okay, so the capital T is t equals to 29. Okay, can see? Okay. Alright. Next one is calculate the speed of the skydiver after 10 seconds and after 32 seconds. Okay, for this, right, please take note that the time given, okay, the seconds, right, is whole number. So use table, don't use graphs. Okay, you will only make your job harder if you choose graph. Okay, only thing is when you choose table, you have two tables to look at. Okay, the left and the right. So if it is 10, it is less than 29, right? Okay, so you should be looking at this table, the first one. Okay, go and locate where's your 10. Okay, get the number out. So V10 is equals to 54.5. Okay, meter per second. And then your V32, you should be looking at this table. Okay, because it is more than 29. 32 is more than 29. Okay, so that will give you 23.5. So as you can see, the speed is lower because you open your parachute already. Okay? Right, the last question. Assume that the skydiver's parachute failed to open. Okay, good thing. So write down the terminal downward speed of the skydiver. So what is this terminal downward speed? Is that when you dive or you keep falling, okay, your speed cannot be increasing forever, okay, or infinity or something like that. Okay, there will be a certain speed that you reach. Okay, the reason that happens is because of air pressure, okay, or wind resistance, you call it. Okay, so basically when you jump down, there's a force pushing you up. Okay, so at one point of time, the gravity pulling you down and the force pushing you up will balance each other, and that's when your velocity cannot increase anymore because the forces balance means the resultant force is 0. Resultant force 0 means acceleration 0. This is a physics guy. Okay, so acceleration 0 means the velocity remains constant. Okay, so graphically, you see right over here, if let's say there is no red one, because your parachute did not open, so there is no red portion. So it's just a green one jumping, and then here there's an asymptote. Okay, so I think if you follow from 0 to 60, right, I think your asymptote will be around 59, but mathematically, right, your asymptote should be 60. Okay, how do you know? You take a look at this, okay, or this 60 right at the top, doesn't matter. You just increase the time because it's as time approaches infinity. So if there is a huge number at the denominator, okay, the whole fraction will become 0. Okay, so it's 60 minus 0, so it's 60. So the terminal velocity, okay, should be 60. Okay, theoretically it's 60, but if you were to only refer to your own graph, I think you cannot reach the 60. I think you will give some answer of 59, but 60 should be the answer. Right? Okay, so that's the end of question 6. I'll do question 7 next. Okay, Assalamualaikum.